All right, so we are looking at some of the kind of basics in setting up an experiment today. So our essential question is, how can we set up an experiment? So first of all, we have to kind of distinguish what things are experiments and what are not. So when you're doing a study and collecting data, things typically fall into the category of observational study or an experiment. An observational study is when we're observing the individuals but not influencing their responses. Sometimes people see the word observes and they think they have to physically be watching when something happens. Um, this can also be kind of collecting data that already happened. Say, I want to look back at a student's GPA, so that's something that already exists, and maybe I'm also looking at their IQ score. So they've already taken an IQ test, they already have the GPA. I'm just kind of looking at the two things together. So you don't have to be physically watching them um, take the IQ test or physically watching them earn their grades or anything like that. It's just kind of observing data that you didn't have any influence on. An experiment then imposes some sort of treatment. So this may be I'm assigning certain people to take medication, or I'm assigning certain students to take a class with one teacher and other students to take a class with another teacher. So that would be my treatment, what I'm doing to the students or the subjects. All right, so confounding is something that kind of sometimes works its way in here. So confounding happens when there are other variables influencing the response variable that are not taken directly into account or easily identified. So there's almost always something confounding or other variables. Like, let's go back to the IQ score and GPA. There are going to be a lot of variables that determine somebody's GPA, not just their IQ score. So what classes are they taking? Are they challenging themselves? Are they taking really easy classes? Things like that. So just something to keep in mind that we may not be able to say our explanatory is causing our response because there are going to be other variables that we need to take into account, or maybe think about, are there other variables, things like that. All right, so let's do a little check here on page 237. So this is where you pause the video, you crack open your textbook and actually look at that check, try numbers 1 through 4 here, and then come back and see how you did. All right, so in question number 1 then. So they want to know observational study or experiment. So the first thing I'm thinking is, did they impose some sort of treatment? And yes, they did, so that makes it an experiment. So they determined what the brightness of the screen would be. So whether people could adjust it on their own or if it was already set for them. So that's the treatment. So they were put into a group that could adjust it or if it was already set. All right, number 2 then. So we want to first determine observational study or experiment. So this is just an observational study. So we're looking at how many meals students ate with their parents. So we didn't assign students to eat a certain number of meals. We're simply observing what they did, what has already happened. All right, number 3 then, the explanatory and the response variable. So the number of meals per week eaten is, we're trying to see if that can explain GPA here. So that would make GPA our response and the number of meals eaten the explanatory. All right, number 4 then, why can we not establish a cause and effect relationship? So there are definitely going to be other variables to take into consideration. If students working a lot, that's going to affect their both their GPA and how many meals they have home with their family. If they're working at night, they're not going to be able to have dinner with their parents all the time. Overall IQ is going to depend on what your GPA is, the classes you take, all sorts of things. So there are probably a lot of other things we need to consider here. Now that doesn't mean we can't explore the relationship, but it just means it's not the end-all be-all. We still have things we need to consider. All right, so some of the very basic experiment vocabulary here. So a treatment is the condition that's being applied. This is your explanatory variable. This is what you are assigning your subjects or experimental units to do. So sometimes this is like a medication. Sometimes maybe I'm assigning people to do a specific type of exercise or meditation. It could really be anything. Just what are you doing? In the last example, if we were to assign the number of meals, like this group of students is going to have 2 meals with their family, this group is going to have 4, something like that, that would be your treatment. Experimental unit then is the individuals that are being experimented on. So sometimes people, not always though, maybe dogs are experimental units, or tables, or trees, things like that. It could really be anything. It's basically what you're collecting your data on. All right. If your experimental units are humans, then we call them subjects. So subject is just a specific type of experimental unit. Placebo, then, I bet a lot of you have heard of the word placebo. Placebo is just a dummy treatment. So maybe you're running an experiment where you want to see if a certain type of medication works. So you give some people the actual medication and you give other people a pill, but a pill that doesn't contain any sort of active ingredients. It's not actually going to do anything to them, but they think they're taking medicine. And the reason we do something like that is because of the placebo effect. So sometimes people think just because they're taking medication that something is going to get better or something about their body is going to change. So sometimes it's consciously, like I'm taking this, so I'm definitely going to feel better in a few hours. Sometimes it's, subconsciously, something that we don't really know we're doing, but we are in fact doing it. So the placebo effect is when a subject reports a change after being treated with the placebo. So the human mind kind of does some funny things. I always think about this, like if I have a headache and I take some medicine and I think, well, did my headache really go away, or do I just feel like it's better because I know that I took something? All right, the control group then is the group that receives no treatment. They could receive the placebo then because they're not technically getting anything different since the placebo doesn't contain anything. And the reason we want a control group is we want to be able to compare. Say I have a group of people with headaches. So I'm going to split them in 2 groups, give one actual medicine, give the other a placebo, and say I reassess after 4 hours. Well, sometimes just the fact that time has passed is going to change things. Maybe, just time passing has helped that person's headache. So we need to be able to compare to that. So has the fact that time passed affect whatever response variable we're measuring, or is it actually the treatment? All right, double blind then. So double insists that there are 2 things. Blind is somebody is not knowing something. So in our case, neither the subject nor those measuring the response variable know which treatment was received. So in order for it to be double blind, both of those have to be true. If just one of them is true, we call that single blind. So you'll be asked if things are double blind. So you have to take both into account. So you would talk about why or why not the subject would be able to know what their treatment is, or the person measuring the response variables. So think about if you're giving somebody medication and there's also a placebo, they're not going to know if they actually got a treatment. And the person kind of assessing their headache wouldn't necessarily need to know what medicine they got. Now, sometimes this isn't possible. So I've seen a problem on an AP test where they were looking at lowering cholesterol, and some people got a medication, some were given an exercise routine that they were to do every day, and others did meditation. So in that case, the subject's going to know what treatment group they're in. They're going to know if they're getting medicine, or if they're told to exercise, or if they're told to meditate. Now, the person that's measuring their blood pressure in the very end, though, doesn't necessarily need to know what treatment group they got or they were in. So you kind of have to think about both sides of it and explain whether or not they can both be blind. All right, so let's do a little check here. So this is where you pause your video go ahead and read and try that out. So you're just doing numbers 1 and 2. There's a number 3 there as well, but you're just looking at 1 and 2. So go ahead and pause and give that a try to kind of see where you're at here. All right, so we're looking at pregnant women. Some received an ultrasound, some did not. So did the experiment design take the placebo effect into account? So no, they did not. So some women who received the ultrasound, perhaps if they saw the image of their unborn child, it might encourage them to live a healthier lifestyle. They might feel a connection with that unborn baby then, seeing them on the screen. And it could maybe cause them to be a little healthier and therefore have healthier babies. So this is all potentially, hypothetically, could this happen? So, and here, no, they didn't take the placebo effect into account. So just because an ultrasound is being done doesn't necessarily mean the babies are going to be healthier. There are kind of some other variables along the way. So simply just having an ultrasound could cause some other variables to pop up. All right, the second one then, was this double blind? So nope, definitely not double blind. So I'm thinking about both people here. So the subject and whoever is measuring kind of the overall health of the baby in the end. So the person assessing the health of the baby would not have to know whether or not the mother had an ultrasound. But the mother is definitely going to know whether or not she had an ultrasound. So this could not be double blind. We would say this is single blind. All right, so this is kind of the basic setting up an experiment here. So first thing we're always going to start with is random assignment. So experimental units are assigned to treatments using chance or randomly. So this could be like an SRS most of the time here. So the important thing about this is we want our treatment groups to be kind of as similar as possible because we want to have a good basis for comparison. So I would want treatment groups that are similar to each other so I could compare them in the end. And that's what random assignment will kind of do for us. It'll theoretically create treatment groups that are similar to each other. All right, so this is randomized design, or sometimes your book or the AP test says completely randomized design. So if they ask you to set up an experiment in that way, this is kind of a flow chart that will contain all of the things they're looking for on the AP test. So let's kind of go through the pieces here. So I'm always starting with random assignment or random allocation. And the next thing I need to decide is, well, how many groups do I need? So you would have however many lines and arrows here for however many groups you have. Sometimes there's only 2, so that would be your minimum. Sometimes there could be up to 3, 4, 5, 6. It really just depends on how many different things you're looking at. So you would set that up. So when you say these groups, you're literally going to write group 1, group 2, group 3, and then you say how many subjects are in each group. So a lot of times you'll split it evenly. So if I had 60 subjects total, I would say 20 subjects in each group. Sometimes it doesn't work out as nicely, so you just get kind of as close as you can. All right, from there, you're talking about what you're doing to each of these groups. So you would say treatment 1, and then where the X's are, you write what that actual treatment is. So treatment 1, blood pressure medication. Treatment 2, meditation. Treatment 3, exercise routine. So you're saying what they are and where those X's are. So you need words there. All right, and the very end then, this is the most important part, we're going to want to compare these 3 treatment groups. Okay, so it's not enough to just say compare. So this green right here, that has to be filled in. So what are you comparing in the end? So what is your response variable? So in the blood pressure problem I was talking about, in the end, I would be comparing blood pressure between the 3 treatment groups. So comparing, and then what are you actually going to be measuring? So let's think about an example. So we want to see if a certain drug improves acne, and we have access to 50 acne patients. So I'm just looking at a certain drug. So that's one treatment they're giving me. Now I have to have more than one treatment group because I've got to be able to compare something. So I'm thinking 2 groups here. So one group for the drug that we're studying, and another for they could either get nothing or they could get a placebo drug here. So I'm starting off with random assignment, and from that I'm going to split into 2 groups. And since I had 50 total, I'm going to put 25 subjects in each group. From there, I have to say, what am I doing to each group? So the first group is going to get treatment 1, and they're going to get the acne drug. The second group is going to get the placebo drug. Okay, so it doesn't matter which is which. You just have to, you're kind of just showing your organization here. All right, after the groups have received the treatment, in the end, I'm going to be comparing them. And what am I comparing? Well, my response would be, did the acne improve? So the acne symptoms. So I want to make sure I have this placebo group in here because sometimes time changes things. So the second group is going to allow me to see, is the drug helping or was it simply that time passed? So in the end, I'm comparing the acne symptoms. So anytime you're asked to set up a completely random design, this is what they're looking for. So you could write out, I'm going to randomly assign 25 subjects to 2 different groups, but this kind of flow chart here has everything that they're looking for on the AP test, and it's kind of a nice way to organize it. All right, so you guys are now going to try on page 247 a check. Problems 1 and 2 there. So in the first one, they ask for a completely randomized design. And they also say write a few sentences. You can just go ahead and do one of these flow charts. That's all I'm looking for there. Okay, so this is where you pause and go ahead and try those 2 problems. Okay, so number 1, they told us there were 29 subjects and they split them 15 and 14. And they even told us that the 14 students were going to evaluate their performance alone and that 15 students were going to evaluate their performance in a group. So I already know my groups have 14 and 15 students. The group with 14 students, I'm going to call that treatment 1, so it really wouldn't matter. And those are the students that are evaluating alone. That's their treatment. That's what we're doing to them. We're making them evaluate alone. So that is their treatment. Treatment 2 is evaluating in the group. They're being assigned to do that. In the end, then, what do I actually want to compare? I want to compare the accuracy of the final performance evaluation. And they tell us that kind of right in the problem there. So in the last sentence, at the end of the semester, the discussion group students evaluated their final performance more accurately. So that's what we were measuring. All right, number 2 then. What is the purpose of the control group? So the control group would be the ones that are evaluating alone. And this is just to provide a baseline comparison, and that's always really the purpose of a control group. I want to be able to compare to what would happen if I didn't have this treatment. Okay, so kind of one last just little tiny thing here is statistical significance. So there are 4 big topics in AP Stats, and statistical significance will actually be what we spend the last few chapters on in this class, but it's worth kind of bringing up now. So statistical significance is an observed effect so large it would rarely occur by chance. So we'll spend a lot of time in the coming months here actually digging into this, but what this essentially is talking about. So if I go back to the let's go back to the acne one. So what I would want to look at is comparing the two treatments here. Not only did they react differently, but how much. So statistical significance kind of measures the how much part of that. So maybe both groups had reduced acne, but maybe one was way more than the other, then we would say that's statistically significant. If they change but only a tiny bit, that might not be statistically significant. So here, accuracy of final performance evaluation, maybe the average for evaluating in a group was 89% and evaluating alone was 88%. So even though this group did better, is there really a difference between 88 and 89%? Probably not. So we would say that's not statistically significant. So what we'll do in the upcoming months here is we'll kind of establish that line of, well, is 87 and 89 a big enough difference? Probably not. What about 86 and 89? So we'll kind of look at where is the line drawn where we can say, yep, there was a difference. But for now, we're just saying statistical significance is there's a large enough difference for us to say, yeah, this treatment really is making a difference, or there's a difference, but it's not really big enough, so maybe the treatment's helping, but we're not really sure because there wasn't really a big change.